Hello everyone, welcome to Root Smart Class. I'm Sachit Somana and I'm your guide for science. So today I'm here with a very brand new chapter that we are going to discuss today, that is light. We all know light is very much important for us, right? For example, we have to see something. Light is the most prominent, source that we are able to see the stuff which is around us. So in this particular chapter, why are we going to study this particular chapter? It's all because of the phenomena, right? So we call light as a natural phenomenon, right? So we have two types. One is reflection and refraction, which has been studying from our lower classes. So we have been studying what do you mean by reflection? What are the properties of light? What is refraction? So all this stuff we have been studying. In this chapter, what is new that you are studying is all about mirrors and lens, right? We use not about the plane mirrors. We are not talking about plane mirrors here. We are talking about mirrors called concave and convex. So we will study about that because that is a spherical mirror which is cut into two types of mirror, that is concave and convex. And how does it look and what are the properties of those mirrors that we are going to study in this chapter, along with lens. Even there we have concave lens and convex lens. So what are its property, how the images are formed. So that's what we are going to study in this particular session. And in this chapter, I want everyone to concentrate from the beginning because the first two sessions will be all of basics. Okay, so we have to understand few rules, how to draw a diagram, what is concave, how to draw a concave mirror, how to draw a convex mirror. So what are the terms related to these mirrors and lens? All these instructions will be there in the first few sessions. So if you follow that, if you understand that basic rules, then it will be a dead easy chapter. Again, this chapter will be a very important chapter, as due to COVID, as you all know, the syllabus has been reduced and they are concentrating on very less chapters. So obviously the number of questions coming from each chapters will increase, the probability will increase. So I want everyone to be alert and understand the concepts, and we'll continue, and we are going to enjoy this particular session. Especially this whole chapter is very interesting because we are going to learn a lot about our mirrors that we use in our daily life, right? We use plane mirrors, but since we are not discussing that because we are already aware of what are plane mirrors, how does it look. So if you go and stand, start grooming yourself in front of the mirrors, you know what it is. Now, how does this spherical mirror, how this concave and convex is different, and where are the applications of these mirrors? Where do we use this? Where do we utilize such mirrors? So that's our question, and we are going to answer those questions in this particular chapter. So let's not waste the time. So let's begin our chapter, light, reflection and refraction. So let's begin our first session. So here we will be discussing lot about the basics. So let's start with that. So light. What do you mean by light? We all know that light is a form of energy. And it is the main reason, the light is the main reason or main source which is making the humans or the animals or any living organisms to, not considering the plants, but again plant is utilizing light, right? It is utilizing light in the form of energy where the plants are preparing its own food. But when it comes to human beings, we are also getting energy, which is like vitamin D, right? So which is more essential vitamin required for the humans. At the same time, this light, which is a reason for the things to be seen, right? We see a lot of stuff, a lot of people around us. We see a lot of a car moving, a bus moving. We see people walking. We see fish. We see animals. We see birds flying. So what is the reason for that? Things are being seen to our eyes. That is because of the light. Okay, so light is a form of energy which enables us to see. Okay, so these properties and all you have already studied. So it's just in previous knowledge. I'm just brushing up the knowledge what we have already about light. So properties of light, we know it is an electromagnetic wave, right? And it does not require any medium. That means even in space the light travels very easily. Okay, but when it comes to Earth's atmosphere, okay, when it comes to a medium where Earth's atmosphere, like a lot of dust particles, a lot of water molecules, a lot of air particles are present in our atmosphere. When it comes to that medium, the light scatters. Okay, so light scatters, a lot of phenomena will happen. So So reflection and refraction is one of the phenomenon. Then apart from that, we have dispersion that we will be studying at this end of this chapter. Then we will be discussing about scattering, right? So all these things are the natural phenomena which is happening because of the light, and also total internal reflection, very important. Fine. Then the light tends to travel in a straight line. Even this we are aware of, correct? The light always travels in a straight line. Even we say, sir, it bends, correct? Light bends, correct? But after even after bending, for example, there is a object here, some slide or something like that. The light will come here and it will bend. Even after bending, it is not like it is going in a curved path. It is even after bending, after certain angle. Okay, light always bends with certain angle. So after it is bent, then what happens after bending? Again, it starts moving in a straight line. Fine. So when it goes to a different medium in the sense like in air, the light is traveling straight. But once it goes to water, the light entering into water or entering into a glass, that's a different medium. So when it enters, it bends. So why does it bend and all the stuff we will study in the next coming slides. So you have an idea that it tends to travel in a straight line. Obviously, yes, it bends at an angle. But why does it bend? Because when it enters from one medium to another medium, it bends. Okay. Then light has a dual nature. That is, it has wave nature also, and also it has particle nature. So when it comes to particle nature, we call it as photons. Okay. Photons are those like light particles. We call it as photons. Okay. Light particles, sunlight particles are called as photons. And also wave. We know what is wave, right? Electromagnetic wave, radio waves, and all this stuff. So wave, it also has wave nature and also it has particle nature. Fine. So in deeper you will study in class 12. When you study more into reflection and refraction in class 11 and 12 you will study. But now, as of now, you can just remember that it has dual nature, it has wave property and also particle property, right? Light casts shadows. We know that, correct? When we are walking, when the sun is directly above us, then we don't find shadows. Shadows will be there, but there will be a different angle. If the shadow is behind us, then we will find our shadow in front of us. Correct? So, light casts shadows. Then, the speed of light in air or in vacuum is 3 into 10 to the power 8 meter per second. We know this. Correct? What is the speed of light? 3 into 10 to the power 8 meter per second. Correct? Now, there is one more question I want you to find out. You need to find out what is the speed of sound. Okay, speed of light is, we are aware, we have been studying from class 9 also, because we are using this value, right? In our calculations, in our numericals, we used to use this. Now, I want you to find out the answer for what is the speed of sound in air or vacuum. Clear? Now, when light falls on any surface, sir, it's not complete. What is this last sentence? You have just written why. When the light falls on any surface, what is the continuation? The continuation is, when a light falls on any opaque object. What do you mean by opaque? First of all, opaque is which is not transparent. Examples of wood. Can you, for example, you have a wooden frame in your home. Just take an example of door. You have a door is made up of wood. Okay, most of the houses. So you see, you stay in your room, and can you see the hall, or can you peek into someone else's room? No, right? Why? Because wood is opaque. We cannot see what are the things happening there because it is not transparent. Few examples: stone, right? So these are the things which are called opaque. What are transparent? Transparent means which light enters into it. Okay, which light enters, when a light enters into a glass, and I'm able to see what is happening in the other side. Okay, which can be seen on the other side, then I call it as what? Transparent. Best example is glass, and also water. Like if the water volume is less, like in a glass of water, if you have, in a tumbler, if you have a glass, water, you can see the things which is there on the other side. Again, it depends on what type of glass you are using and what quantity of water, what volume of water is there in that particular glass, right? So when a light falls on opaque object, we have a phenomena happening there, that is reflection, right? And when it is falling on a transparent object, then it is refraction. So these two concepts or natural phenomena, what we say, based on this, how do we study? What do we study in this chapter? That's the most interesting part that we will see in this particular chapter. Fine. So first we understand what is reflection, then we will study about refraction, then how reflection and refraction is being applied in different devices. That is what we are going to see. Okay. So let's begin with the first phenomena, that is reflection of light. Okay. The phenomenon of bouncing back of ray of light when it is incident on a polished surface. Okay, beautiful definition, but from this what you understand? Okay, very simple. Now you go to class, you have a desk, right? So under the desk, the whatever writing surface you have, below that you will be having space so that you can keep your belongings like books or maybe bag. You will be having some space. Now from the top, when you see, can you see the space what you have, like if you have kept some book from the top, are you able to see that what type of books you have kept, like how many books you have kept? Are you able to see? No. Why? Because that particular surface is an opaque object. Correct? Similarly, mirror is also an opaque object. Okay, mirror is also an opaque object, but mirror is made up of glass. Okay, on top of a glass, you will be having a coat which is an opaque coating. Okay, they say opaque coating will be done. So that opaque coating makes glass as what? It makes the glass as an opaque object. Okay, any one side of the glass will be polished. Okay, opaque coating we say. So when they do that coating, the mirror which is made up of glass, it becomes as a opaque object. So reflection is happening only in where? It is only happening in opaque object. It doesn't happen in transparent object, that is glass. So if the light, because we know the light enters into the glass, right? The light will penetrate inside the glass. So penetration, when it gets penetrated, the phenomena is totally different there. But when it comes to reflection, that is a total concept. Now again, you can give a lot of simple examples, day-to-day life examples that you can quote. For example, you have tennis ball and I think or basketball. You people will have a habit of dribbling the ball, correct? You will dribble. How do you dribble? You just push the ball to the ground. So what happens? It bounces back. So reflection is something when a light falls on a polished surface. Polished surface is nothing but opaque object. Okay. If a light falls on that polished or opaque surface, the light will bounce back. But how does it bounce back? Is there any criteria for that? Obviously yes. We have a criteria and we call it as angle of incidence and angle of reflection. So as you can see this diagram, I'll just clear it. Yeah. So as you can see this mirror, as I told you, it is an opaque object due to the coating they have done. So it is completely polished and it has become a opaque substance. Now a ray of light, incident ray. Now just seeing the diagram, you might have a doubt. Sir, is it the only single light ray will fall every time and it gets reflected? So it is just for our understanding that we draw like that. Okay, imagine light is beam of ray, or we say beam of light. Beam of light in the sense, in that beam of light you will be have millions of lines. We know the light travels in a straight line. So that light will be having numerous, like millions and billions. A small beam of light, for example, this thick. So in this thick, beam of light, there will be plenty of light lines or ray of light will be passing, and when it falls on the surface, it gets reflected. All the light rays will get reflected, something like this. Okay, so the light which is falling on a surface, the light which is falling on a surface, opaque surface, we call it as incident ray. Okay, and again, when you are in this particular chapter, there are a lot of diagrams that we have to practice. So when I'm doing some, explaining some diagrams over here, you have to make sure there are certain rules that you have to follow. Okay, and it is very strict that you have to follow, because if you miss out even a arrow mark, see, you can see a arrow mark here, which is saying the light ray is going in that particular direction. Okay, what does the arrow mark says? Arrow mark is nothing but it says about the direction of the light. So let it be very clear. If you miss out these direction, if you, even if you forget to write the directions, you will be losing your marks. So let's practice that from the beginning of the, from the first slide. So we will start practicing writing the arrow marks on, exactly on where has to be mentioned and all the stuff. And also labeling part, when you're writing a ray diagrams or it may be any diagram, the labeling has to be very perfect. Clear? Fine. Now, coming to the incident ray. So, incident ray is nothing but I can call it as incoming ray. Don't call it as incoming call. Okay, incoming ray in the sense like the light which is coming from the sun, which is made to fall on the surface. Okay, which is made to fall on the opaque surface. Now, after it comes and makes a contact with the surface, it gets reflected. That is what the definition says. Bouncing back of ray of light. So the ray of light is being made to fall on the surface. Now it has to get bounced back. Now bounced back, when it is bouncing back, that ray or that light, we call it as reflected ray. Okay, we call it as what? Reflected ray. So incident ray is the ray which is coming and falling on the surface. Reflected ray is bouncing back of light. Okay, that process is called, that phenomena is called reflection. Now, when this happened, when they, a lot of, researches were happening, when this happening, so people started, okay, we should find the angle also. Then it will be very easy for us to understand what is reflection. Like we can make a difference between reflection and refraction. And that's how we got angle of incidence and angle of reflection. Okay, angle of incidence and angle of reflection. So what is angle of incidence? Angle of incidence is like with what angle did the light fall on the surface? Okay, or what is that angle with which the light falls on the surface, and what is the angle of reflection? That is, angle of reflection is at what angle the light got reflected. That is what the angle of incidence and angle of reflection. The angle of incidence is being represented by the letter I. Okay, don't use capital letter I and all. You will be using angle of I will be small letter I and R. Okay, angle of reflection and angle of incidence. So what is, you can see by the diagram, you can see this angle of incidence is on the left hand side, angle of reflection is on the right hand side. And don't think that it is it is like confined for this particular diagram, or it is like, that's the criteria that we have to draw it like this. It's not like that. Whatever may be the direction. For example, if I write the incoming, that is the incident ray on my right hand side. So where will be my reflected ray? Reflected ray will be like this. And you have to mention the direction also. On what direction, in which direction does it going? Correct? It has to be mentioned. For example, I can write it in a slanted way also. For example, just say this is the surface. This is that polished surface. Now, if the light is falling like this, I'll put the arrow mark like this. Right? Obviously, the reflection will be in this way. Or if I put the surface on the top and the light is falling here, this will be like this. Okay, the reflected ray will be like this. Then, as you can see in the diagram, there is one, dotted lines that we have drawn. We call it as normal. Okay, what is that normal is? Normal is something that you draw to the surface. Surface of what? Of the object. Okay, surface of an opaque object will be there. To that, if you are drawing a dotted line, which is obviously perpendicular on both the sides. Am I clear? The normal that we draw, the dotted lines that we draw, we are drawing the line for the surface, the opaque surface, the mirror, what we have written here. So that is 90 degree. Normal in the sense perpendicular, right? So 90 degree. Now, what we say from this is that is I is equals to R. What is that I is equals to R is nothing but that is a law of reflection. So it says that whatever angle the light incidents, it gets incidented. Okay, with what angle the incident ray falls on the surface, with the same angle it gets reflected. That's what the law of reflection says. You can see here the angle of incidence is equals to the angle of reflection. Very simple. Just say okay, this is the surface, the light is falling, this is the direction. Now just say this is 30 degree. Okay, the light is falling on this particular surface as 30 degree. The reflection will also be how much? It will also be 30 degree. That's what it says. Or I can say, if this is that reflection thing happening, concept is happening, if I say this angle is 60 degree, okay, the whole angle is 60 degree, then I draw a normal. Now it becomes 30 degree here, 30 degree here. In case if you tell 120, the whole angle is 120. So you divide this, it becomes 60 here, it becomes 60 here. So that's how whatever angle of incidence will be there, the same angle of reflection will also be there. That's the law of reflection. Second point, the incident ray, or the second law we say, the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. So what does this mean? They are saying that, see, we know this is the incident ray, this is the reflected ray, and this is the normal. These three lines, where is the place that they are coming into contact? Obviously this point, correct? This is that point of meeting point. Okay, all the 3 points are meeting at this particular point, which is in contact with what? Surface. So they say that all these 3 lines, whatever normal, incident ray and the reflected ray, all lie in the same plane. What do you mean by plane is, okay, I'll use this pens to explain that. Just say this is the incident ray, it gets reflected, okay, like this. I'll load it like this, correct? This is the incident ray and it gets reflected. At the center, I'll draw the normal. Now, they are saying all these lines which are meeting at one point, you can see these are the 3 lines. Okay, these are the 3 lines. Now, when I see like this, it is all in the same plane, like it is straight. It's not like this line is like this, or the reflected is somewhere here. It's not like that. Everything is in a straight line, okay, in the same plane. So that is what the second law says. Okay, so this is reflection of light. So remember, very important, angle of I will be equals to angle of R. Diagram, direction, incident ray, angle of incidence, normal, all this stuff is very important. Then you can see one more diagram here, which is called regular and irregular reflection. Regular reflection means the surface is very smooth or polished or plain, very plain. Irregular means it is having humps somewhere here and there, like not even surface, uneven surface here and there. Even though if the surface is uneven, we call it as what? Irregular surface. Even in that irregular surface, the angle of the loss of reflection will follow. That means if the light falls on this, okay, due to due to some, what do you say, irregularity, that is unevenness, the reflection angle may look different, but the angle will be same. So even in regular reflection, even in irregular reflection, that is just an information. Okay, regular and irregular reflection, you will find that in both the type of reflection, you will follow the law of reflection. The light will follow the law of reflection. Okay, now coming to refraction. Okay, again, I'm telling you, reflection and refraction is very much important for us to understand this chapter. Okay, so what is refraction? Again, refraction is nothing but bending of ray of light when it enters from one medium to another medium. Now here we have to understand what do you mean by that medium. Okay, what do you mean by that medium? For example, in our education field, we have this Kannada medium, English medium. So what is that? So the study instructions, whatever we study, it will be in Kannada medium. When it comes to a convent or English medium, the course of instructions will be in English. But here the course of instructions will be in Kannada, right? Or Tamil medium or Sanskrit medium. So the course of interacting or communication, or maybe the instructions, whatever the teacher gives, everything will be in that regional language, right? So here also, when it comes to light, we have different mediums, right? Water is a different medium. Atmosphere, that is air, is a different medium. Glass is a different medium. So only these three are very important as of now. Okay, that is the main three basic mediums that we will be studying about light. Clear? So what are those? Air, water and glass. So these are the three mediums. Now, as the definition says, the bending of ray of light when it enters from one medium to another. So from this, what we can understand is, just imagine one medium is air, the other medium is water. Okay, from air, obviously, yes, the light is going to enter or travel straight. Even in water, the light will travel straight. Even in glass, the light will travel in a straight line. So let it be very clear about it. Okay, now when this light, which is there in air, when it enters water, maybe like in ocean, maybe in river, right? So when this light enters the water, there is a bend of light. Okay, there is a bend of light. For example, I want you to do this experiment at your home. Okay, since I have a very simple activity that we have been doing in our lower classes also. What we do, we take a glass of water, fill the water is filled in the glass, put a pen or a pencil in it. What do you see? Right? So I want you to do this and understand here. So as you see, observe the glass from the outer environment, you can see there is a small cut, or it feels like it is a small cut, but it is actually a bend of light. Why? The reason is, so let me clear out this part. Okay, just say air is one medium, water is one medium. So when the light enters from air to water, it bends. Okay, the reason is the speed of light is different. Okay, the speed of light is different in different medium. That's the main reason. That is the only reason. That is the why the light is bending in a different medium. Why? Because of the speed of light. This in air, we know it is already 3 into 10 to the power 8 meter per second. This is the speed of light in air. In water, it is 2.5 into 10 to the power 8, which is more. Obviously, in air, the speed of light is more because it is 3 into 10 to the power 8. But in water, it is 2.5 into 10 to the power 8. In glass, it is 2 into 10 to the power 8. Okay, these are approximate values, not the exact values. So when we calculate, we use these values. Okay, but calculation is not there for you. Class 11, you will study this. Okay, so air 3 into 10 to the power 8 meter per second, that is the speed of light in air. Inside of water, it is 2.5 into 10 to the power 8. In glass, it is 2 into 10 to the 2 into 10 to the power 8. Okay. Now, so now you understood why the light, when it goes from air to water or air to glass, it bends. The reason is the speed of light. Now, few more things that you have to be very clear when it comes to refraction is, see the diagram here, you have an incident ray just like a reflection. Even in reflection we add incident ray. What is incident ray? Incident ray is nothing but a ray which is falling on something. Okay, here we are saying boundary. Boundary means where the air environment is ending. This is the region where air is there, correct? So the boundary means it is the boundary for air. Then it starts with glass. Okay, here we have taken glass and air. So below this is glass. Starts after this boundary, the glass will start. The glass medium will start. Above this, the air medium will start. Fine. So the incident ray from the air will fall on the glass. Clear? So as you can see, that ray of light which was supposed to go like this, which was supposed to go straight, it is not going straight, it is bending. The reason is speed of light in glass is less. Okay, the speed of light in glass is less. How much? Here it is 3 into 10 to the power 8. Here it will be approximately 2 into 10 to the power 8. Okay, so 3 is more, 2 is less, correct? So when it goes from higher speed of light, medium, to a lower medium, lower speed of light, medium, so obviously it will bend, but it will bend towards the normal. So keep this in mind. Okay, when a speed of light which is having 3 into 10 to the power 8, that is from the air, when it is going to glass or water, I'm adding this, or it can be water also, because why? Even water has less speed of light when compared to air, right? So it will be bending towards the normal. What is normal again? Again normal, see in the reflection I drew only till half. Here I am extending till the bottom. Why? Because we have two mediums. And refraction is happening only in transparent objects or transparent surfaces. If I keep an opaque object here, instead of a glass, if I keep an opaque object here, do you think refraction will happen? No. Refraction will not happen. Reflection will happen. But here, since glass is a transparent, the light is entering inside the glass and it is bending towards the normal. Why it is bending towards the normal? Because air is having more speed. The light speed is more in air when compared to glass and water. Okay. Now, just imagine this is glass medium and this is air medium. Now, the light ray is falling. So this will be my incident ray. Okay. I'll draw the normal also, both the end. It is normal. Okay, diagrams has to be very precise or else you will lose marks. Fine. Now, in glass, if I say it is 2 into 10 to the power 8, here it is 3 into 10 to the power 8. And the glass is, the light is coming from glass medium. Now, where does it bend? The question is towards where it bends. It will bend away from the medium. It will bend, but it will bend not towards the medium. It will bend away from the medium. Why? What is the reason? Because the speed of light will increase when it goes to air. This is angle of incidence. This is angle of reflection. Correct? The glass is having 2 into 10 to the power 8. Now, when it is going out of the glass, when it is going to air, the speed of light is more. So when the speed of light is more in the second medium, the reflection what is happening is going away from, I'll write it here, going away from the normal, but here towards the normal. So this is one trick that you have to keep in your mind. When it goes, you can remember like this: from air to glass and water, from air to glass and water, the reflection is towards the normal. From glass or water to air, it is away from the normal. So you have to remember this. Fine. Then, so as I told you, refraction is nothing but bending of light, and this refraction happens only for transparent object, and also it happens for translucent also. What is translucent? Translucent means it is partially opaque, partially transparent. So in that case, what happens is few will reflect and few will refract. Okay. Water surface. In water surface, I told you that water is transparent. Correct? Water is transparent. But have you ever thought, this is a very interesting question that I am going to ask you right now, that we know that water is transparent, correct? But still, you can see your reflection in water surface, correct? You go near the river, you go and stand near the pond, okay? You can see your reflection, but we said it is transparent. In transparent, refraction happens, reflection doesn't happen. So what do you think about it? So water surface, not only surface, okay, water surface, it acts like a translucent surface, okay. In translucent, what it is, like it reflects also, it refracts also. So that's the reason you can see your image, you can see you on the water surface, right? You can see the image. See, you are the object. When you stand in front of a mirror, a plain mirror or the dressing mirror what you have, you will be seen on the screen as in the plain mirror. That is the image. You are the object and you can see yourself in the screen, that is image. So that's what happening in water also. When you go and stand in front of that water, you can see your reflection, and at the same time refraction is also happening. That means the light is entering inside the water also. That we cannot see, but we can see. But how do we experience that? Right? For example, light is getting reflected on me, and that's how you can see here. We have a light setting here and we are recording here. I can see there are lights over here, and the light is falling on me, it is focusing on me. The light is falling on me, and it is getting refracted to the camera, and that's how you can see me, right? So these are the concepts which makes us to see. But when it comes to water, we cannot see that light is entering, bending, and all this stuff we cannot see. But how do we experience it? By going underwater, correct? When we go underwater, we can see fish. You might have seen National Geography, Animal Planet, where people go fishing. They go for, searching for whale, dolphins. They study a lot about those fishes, right? So when they do, you can see swimmers, the divers, what we say. When they go down, we can see the shark, we can see different octopus, turtles, and all this stuff. Why? Because the light is entering inside. Okay, the light is entering inside. That's how we can see the objects which is there in that environment. Clear? So very interesting, this reflection and refraction. A great discovery we can say, because by this we have learned a lot of things. Lot of optics has been come up with. Maybe your specs, maybe, right? Maybe the television, the camera, we have lens using. So a lot of technologically also we have been improved by knowing this reflection and refraction. Okay, and again, this is a natural phenomena. Okay, humans are not doing anything, but we are using this application and we are utilizing in a very different fields. Right? Okay.